Alright, so this kind of geometry I want to talk about, you actually see this in school quite a bit, maybe in year 8 or maybe year 9. I don't know, you can tell me if you've seen it. But I feel like a lot of it's not really done very well. So if we have like quadrilaterals, yeah. You know, what kind of quadrilaterals do you know? Yeah. You have parallelograms. Parallelograms. So annoying. Yeah, so you can have like, it's almost like a hierarchy. So you have like trapeziums, right? You have a rhombus. You can have rectangles. You have squares. Yeah. What else?
Kites.
Yeah, so kites, I guess, would be like.
It's similar to.
Is diamond like a real shape?
Diamond is a rhombus.
Oh.
Like that.
I think that's it.
But that can't be.
Can you name any other ones?
No.
Okay, let's just say this is it for now, okay? So, and, yeah, you guys all know the definitions of these things, right?
Full size.
So here it's like one pair of parallel sides, yeah? This is two pairs of parallel sides, yeah? Rhombus is like all four sides equal, yeah?
Yeah, but rhombus isn't a square, huh?
Square is like
Also equal and parallel.
all sides equal and no, parallel is already true for a rhombus. And 9 degrees or something, yeah? Rectangles, it's like 90-degree angles, yeah? And it's a parallelogram.
It's got two pairs of parallel.
Yeah, it's a parallelogram with 90-degree angles. What's kite, do you know?
Adjacent sides equal.
Yeah, so it's two pairs of equal sides, two adjacent, two pairs of adjacent sides equal. Yeah? Okay, so I want to prove some properties about these things. I mean, I think the problem, people put too much emphasis on just the fact of them. Our emphasis should be the proof of them. Okay. Did you do this in school already? Huh? Have you?
Yeah, last year.
Yeah, you should have, right? So hopefully you know how to prove them. So the way we have of proving things, stop it. So we use congruent triangles. Does that make sense? So congruent triangles are our way of basically proving everything in geometry. Okay, it usually starts there. And the sort of SSS, SAS, RHS, and AAS. Do we all know what these mean?
No.
Yes.
So if the three sides of the triangles, if two triangles have all the sides equal, then they're congruent. That's what that means.
Oh.
Okay, so if the two triangles have exactly the same side lengths, then they're congruent. Yeah? If two triangles have exactly the same angles and one side length equal, then they're congruent. Yeah? If two triangles have two sides are equal and the angle in between is equal, then they're congruent. Yeah, that's SAS. So side, angle, side. RHS means there's a right angle and the hypotenuse is equal and another side is equal. Yeah, but that's really just SAS. Yeah, that's really just SAS, but the A doesn't have to be in between once you know it's a right angle. Yeah. Okay. Does anyone need a refresher on congruent triangles any more than that? Does everyone know? Okay, so now we're going to use it to prove some properties. Okay, so if you prove, like, some of these things, they can be thought of as alternate definitions, or they could be thought of as properties, okay? You can maybe try to figure out which one's which, okay? So if I have a parallelogram, so one of the key things about parallelogram we learn is that the diagonals bisect each other. Understand what that means?
Yeah. No.
It just means that if you have a parallelogram and you draw the diagonals, then the point where they intersect is the midpoints of each diagonal. Does that make sense? The question is, do you know how to prove that? Can you prove it? Do you know how to prove it?
Like the diagonals are
Bisect each other, yeah.
like you have congruent triangles.
Okay, so you do, okay. Okay, who do you think you guys know how to prove it?
No. Yeah.
You know how to prove it? Okay. That's weird, your school should have taught you this. Okay, anyway, so if you have if you have parallel lines, right? Let me draw it bigger. Alright. So if you have a parallelogram, so one thing you know about parallelograms is these are parallel, yeah?
Yeah.
And that's parallel, yeah? And we want to say something about the diagonal. Yeah?
It goes from one point to that.
Okay. So we know in a parallelogram this angle is equal to this angle, right?
Yeah, because that's the what's it called?
Alternate angles, yeah?
Yeah.
Okay. And we also know for the same reason this angle is equal to this angle, right?
Yeah.
So can you see that means these two triangles are congruent? By what?
Angles. Alternate angles.
AAS. There's only 4 options, okay? Don't make up your own one, okay? So AAS, angle, angle. What's the side? The diagonal, yeah? Okay. So what does that tell you, actually? Well, that tells you, well, it's not going to tell you anything about the angles, you understand? Because you already know the angles are equal, yeah? So what's going to tell you is going to tell you the other missing information, right? It's usually 3 S's and 3 A's. So the 2 S's is what's going to tell you, yeah? So it's going to tell you this is equal to this, and this is equal to this, yeah? So I actually kind of unlocked another property. It's like the opposite sides are equal, yeah? That makes sense? Okay, so then we can draw the other diagonal, yeah? Okay. And for example, we have this angle here is equal to this angle, right? See why that is? Huh? Huh? I said this angle is equal to that angle. Why is that? So alternate angles, right? You learned this at school? Oh, you're supposed to learn it this year at school.
Wait, for year 8 or
I think you're meant to learn alternate angles in year 7.
well, we did learn it this year. We learned like last week, but they didn't tell us like how to smooth it.
Okay. Yeah, you can't prove the alternate angles thing. It has to be like an axiom, basically, for us.
Alternating angle is definition, right? I guess.
Yeah, I mean, maybe that's like your definition of parallel lines, yeah? But it's a bit of a complicated definition. Anyway, so we have the alternate angles are equal, yeah? Okay. So can you see that now? This triangle and this triangle are congruent. Yeah? Okay, now I'll test you why. AAS.
Yeah, AAS.
Angle, and side.
Okay, it's AAS, good. Which side?
The top one.
The top and bottom one, yeah? Okay, so then they're congruent by AAS, yeah? So what can we deduce from that?
Matching sides.
Yeah, I literally told you guys this, the previous one, right? You deduce the S and the S, yeah? So what's the S and the S? Oh. Oh, thanks. Yeah, so wait, what's equal? Okay, how about I draw one of them and you tell me which one it's equal to, yeah? So this side here is equal to something, yeah? Equal to what? This one? Okay, and then this one here is equal to something. The only other one, yeah. That's how I think about it too. But this one is equal to this one because they're both opposite the dot angle and the other one's opposite the alpha angle, right?
Yeah.
Yeah, so what does that give us?
They're all congruent.
Yeah, these equal, so there's a midpoint, right?
Yeah.
The diagonals bisect each other, yeah?
Yeah.
Does that make sense? Okay. Yeah, so can you see how the proof works, yeah? Okay, I propose that diagonals bisecting each other is actually an alternate definition for a parallelogram, okay? So if you have a quadrilateral where the diagonals bisect each other, yeah? That makes sense? Then I claim that that's a parallelogram, yeah? So how do I prove that? How do I prove that if the diagonals bisect each other, then it's a parallelogram?
You do cover around, like, since it's bisecting, the angles are like equal.
Hmm. I need something specific, okay? How do I use this to prove it's a parallelogram? Jay, do you know?
No.
Okay, so remember, it's the same theme. We're doing everything with congruent triangles, yeah? So now we have the same congruent triangles, but we have a different way to prove they're congruent, you see? So here, these angles are equal, yeah? They're what's called vertically opposite, yeah? So they're equal. And therefore, can you see these triangles are congruent, yeah? How are they congruent? This Sean, the most annoying whisperer. So Sean says side angle side, yes? Yeah?
Yeah, because of like those two sides are actually.
Yeah, so you got these two sides, yeah, and then the angle in between them, yeah? So they're congruent by SAS, yeah? So if they're congruent by SAS, what can you conclude? Huh? Huh? What? Huh? I heard someone say something.
Because if the congruent triangle means the parallel.
Yeah, but you can't just get to the end. You have to tell us what's going on. So it's SAS, they're congruent. So you have the S and the A and the S. So what don't you have though? Huh?
The other side
The other side and
the other two angles.
yeah, so you're gonna conclude about them, okay? So what are the other sides? What's the other side?
Side with three lines.
Okay. It's these ones, yeah?
Yeah.
Yeah?
That's why I said side with two
No,
lines.
you didn't describe anything. You made your own little in-joke with yourself. Okay, so these sides are equal, yeah? And you can actually make a similar argument to show these sides are equal as well. So you got this property back, yeah? So the opposite sides are equal, yeah? But what else? What else apart from the side?
The angle.
The angles, yeah? Which angle is equal to what? So this angle is equal to what?
The angle on the bottom.
The bottom, right?
This one, right?
Yeah.
What about this one?
That would be equal to.
Yeah. So can you see what that shows?
The angles are equal.
Yes. And what does that show?
Congruent triangles.
No, the triangles we already know are congruent.
They bisect each other.
No. We assume they bisected each other to start, yeah? And then we prove these angles are equal, yeah? What does it mean for these angles to be equal?
Alternate.
Yeah, they're alternate angles, okay? So what does it mean for these alternate angles to be equal? So now we have alternate angles equal, huh? It means they're parallel, yeah? You understand? You could do the same on the other side, yeah? But that's what we're setting out to prove, yeah? So that makes it a parallelogram, you see? You understand? So one way to say that is the diagonals bisect each other if and only if the two pairs of opposite sides are parallel. You understand? They imply each other. You could start with either one and you get to the other one. Does that make sense?
Yeah.
Yes.
Okay, and you can also start with opposite sides are equal. Okay. So there's lots of these properties, and they kind of really help, they help you understand logic and proofs in geometry, and they're also kind of helpful when you actually use these things, because you're not always given the property that you want. Yeah. Okay, so another one is kites. Yeah. And rhombuses. So one property of a kite. So kites, what was it? Two pairs of adjacent sides equal. Yeah. And the rhombus is all sides equal. So it's like equilateral. Equilateral, quadrilateral. Right. What's a triangle with all the sides equal? Equilateral triangle. Right. Alright, so so if you write this as the definition, it's obvious the rhombus is a kite. Yeah? Yes? Because if all the sides are equal, then two pairs of the adjacent sides are also equal. Okay. But someone mentioned earlier some properties of kites and rhombuses. It was like the diagonals are perpendicular to each other. Yeah? Yeah? That makes sense? And not only the diagonals are perpendicular to each other, the rhombus, can you see the rhombus, the diagonal is actually perpendicular and bisectors of each other. Do you know why? Yes, because they're parallelograms, right? Okay, well, we also have the diagonals. There's one diagonal. So one diagonal is an angle bisector of each vertex of both opposite vertices. Yeah? Okay. And can you tell, and so for a rhombus it'd be both diagonals. Okay? Does that make sense? You think we can prove these things? Okay, think about how you'd prove these things. So have for a kite, the diagonals are perpendicular to each other. Yeah.
Wait, so we just get that all sides are equal and parallel in rhombus.
Mm.
What are we meant to do?
And then the question.
What's the question? Oh wait, I was trying to like prove it.
Yeah.
So what are we doing?
What are you proving?
Yeah, what are we meant to do?
Alright, has anyone already done it? Huh? You're not doing it.
Not using this.
So I mean, we should draw a kite. The kite looks like this, right? It's like a different kind of diamond, I guess. A rhombus looks like this. We're saying that the diagonals are perpendicular to each other. Huh? Yeah, so this is not just about like, oh, you use congruent triangles. It's like you gotta actually pull it off with the congruent triangles, yeah? There's an element of execution here.
Get that. Wait.
I proved that one diagonal is an angle bisector of both vertices. This is the same word.
So basically, like, the lines are like equal.
Yeah, Jay, do you know how to prove that the diagonals are perpendicular?
I don't think so.
Okay, has anyone got anything? Oh, yeah. Let go.
So like the sides in like the two half triangles, the left side and the right side of the height,
Like this, yeah?
get like two congruent triangles there because of side.
Okay, you can see these triangles are congruent, right? By SSS, right? So they have the side that's the same down the middle, and they have side, side, and then this side, yeah? So they're congruent, yeah? So once they're congruent, what can you tell them about them?
The triangles are the same.
The
Yeah.
angles at the top.
Yeah, like if you use SSS to deduce they're congruent, then you conclude the angles are equal, yeah? So what's this angle equal to?
The one right next to it.
That one, right? What's this angle equal to?
Left.
Yeah. So notice we got this angle bisector condition now, yeah? So in particular, I didn't say it properly, but it's the vertices where the sides are the equal sides meet, yeah? So this equal side meets here. So for a rhombus, all four sides are equal, so the diagonals are going to be angle bisectors of all of them, yeah?
Yeah.
Okay. Okay, so we got the second condition, but not the first one. How do we show that the diagonals are perpendicular, yeah?
Like if you take the top triangle, like the entire top side of the kite.
Like this or this?
Yeah, the second one.
That one.
And that's isosceles triangle.
Yeah.
Since we know that it's one of the diagonal is an angle bisector.
Yeah.
We know it's going straight down, and the angle of the straight line
Yeah.
is 90 degrees, 180 degrees, or 180 degrees, and then you halve that and you get 90 degrees.
Yeah, okay, so he's saying,
RHS.
yeah, yeah, so you got that's an isosceles triangle, right? And in the isosceles triangle, the angle bisect, the, yeah, the angle bisectors also perpendicular with the height, yeah? And you can actually prove that just using like congruent triangles. You have AAS, yeah? Or SAS. And then the angle equals the angle, yeah? Does that make sense? Yeah, so yeah, that's pretty much yeah, so okay, so also this diagonal sort of bisects the other diagonal, but the other diagonal is not bisected. The other diagonal does not bisect the first diagonal, yeah? Does that make sense? So this is like the midpoint. You see why it's the midpoint? Yeah, it's again the isosceles triangle. Yeah.
Or SAS.
Yeah. Okay. All right, guys. So the morning bit, the first session is over. If you wanna do some interesting applications of this, okay, I urge you to try this problem. Where is it? So this problem here. So you might be tempted to just to like assume everything looks nice, but the goal is actually to prove it. Okay. So for example, in part B, how do you know that the center of the small circle is the center of the big circle? Okay. For part A, how do you know that the contact point of the middle circles is the same as the center of the big circle, right? These are things you probably just assume and then you don't think about it, but
It's like by symmetry.
I want you to prove it, okay? Yeah, so actually by symmetry, so the question is it by a kind of symmetry that involves the two small circles, or is it by a kind of symmetry that doesn't involve the two small circles? You see? So by symmetry is a bit too vague for me. It needs to, even with symmetry, I think the symmetry should be explained, okay? Alright guys, if you're only for the first session, have a good week.
Wait, I did A, but like, I'm not sure. Wait, I don't like answers.